The hydrograph of a stem is a graphical representation of the discharge variations arranged corresponding to the time, right? Which is, you can say in short, then it is runoff or discharge rate against time. And this is also known as a storm hydrology or else a flood hydrograph, or simply you can call it as a hydrograph. And we are knowing the hydrograph presents the total runoff occurring at a given period of a time. So we are knowing about the total runoff, right? So the total runoff is direct and direct plus base flow, right? So, and this hydrograph is also shows the distribution of a total runoff with respect to time at a certain measurement point. So all kind of a hydrograph are having three regions characterized as three regions. So one is rising limb, and second one is the crust segment, and third one is a recession limb. This recession limb is also called as falling limb, right? So a hydrograph or having mainly with the two types. One is single peaked and another one is the multi-peaked. And the multi-peaked hydrograph is known as a complex hydrograph. So, however, in a hydrologic analysis, many times the hydrograph resulting from isolated period of rainfall ought to be studied and analyzed to calculate volume of runoff. So this is the reason that it is important to understand the various components of a total runoff. So as I said, what is the total runoff? That is the direct plus base flow, right? So, and I mean, that is the total runoff and parts of the hydrograph. So we have the hydrograph is the sum of total of three components. So one is surface so one is surface runoff. So this surface runoff is called as overland flow. And second one is subsurface runoff. And this subsurface runoff is called as a interflow. And the last one is groundwater runoff. So groundwater runoff, or you can call it as a base flow. See, base flow. Okay. So now, here if you see the graph, then this in this graph mentioned 1 and 2 is approach segment. So this 1 and 2 is approach segment. So now to know about the approach segment. It indicates a condition when the stream is fed up groundwater flow or the base flow. And the next we have that this the mention 2 and the crest point P, right? So which is mentioned 2 and P. So this when the rainfall starts, then the increasing contribution to the stream occurs by way of surface runoff and which promotes subsurface runoff. So this is shown by the total rising limb. So this 2 and P is your total rising limb. Okay. So now the peak flow, or you can say that is the highest flow in the stem, is the crest point P. Okay, so the point of inflection on falling side of the hydrograph is commonly assumed to indicate the time at which the overland flow or else the surface runoff stops. So from this point we have recession limb. So your recession limb will be 4 to 5. And this recession limb indicates the withdrawal of water from valley storage or else channel storage. And the valley storage, channel storage is the part of overland flow. So the overland flow is the surface runoff, right? So which does not give dissipted instantaneously, right? So this water, the volume of water, occupies somewhat standby or else temporary way in the space of a river valley or along the bank of a river channel till the passage become free so that the flood can deflect it, right? So in this it is shown that the peak flow occurs sometime after the rainfall has stopped. That is the lag time, which the lag time is the time difference between the entroid of, I mean, the centroid of, no, centroid of rainfall excess and the peak of the hydrograph. That is your lag. So the centroid of the rainfall excess to the peak. So that will be your lag time. So in some situations, if the heavy rainfall is still continuing with some low intensities, okay, so say for an example, for an extra period of a time, 1 hour, 2 hour, whatever, then it is possible that the peak flow shall attain before the rainfall has completely ceased. So the shape of a recession limb or else a falling limb is generally not dependent on the rainfall characteristics, but it is always depends on the basin characteristics. So the basin characteristics is all about its shape, size, slope, nature of valley, its elevation, land pattern, characteristics of a soil, right? So coming to the point with these three important, that is rising limb, crest, and recession limb. So the rising limb is a concentration curve, and it is always in the ascending portion of hydrograph. And the slope or the steepness of the graph is depends on the rise of discharge due to the storage, right? So that is an increase of a storage in the drainage channel, so and as well as over the watershed surface. And this shape is always depend on the storm and watershed characteristics, okay. And also the shape of the rising limb is concave upwards and rises very slowly in the early stage of flow. But when the storm continues and increase of a flow from the distant part reaches to the outlet of the watershed, then the rising limb rises rapidly to the peak point P of the hydrograph, right? So in simple hydrograph, the extent of rising limb is comparatively shorter than the falling limb. Okay, so as a result, the area below its limb is less to that of the falling limb. And now talking about the crust segment, and this is more important because it has the peak flow, right? So, and this is extended from the point of inflection of the rising limb to the inflection of the falling limb, or this the recession limb, right? So the peak flow occurs when various parts of watershed yield the runoff simultaneously to the outlet. So the time interval from the center of mass of rainfall to the peak of control of the stream and watershed characteristics. The hydrograph of some watershed resulted from a single and relatively shorter duration of rainfall, and which will have two or more peaks, and this is called as a multi-peak. This is especially occurs when two or more storms next to next immediately, right? So next we have the recession limb. So to talk about the recession limb, so it is a decreasing of portion. Okay, it is a decreasing of portions, or else you can say descending in the hydrograph. Okay, so this falling limb or recession limb is extracted from the point of inflection of the end of crust segment, end of crust segment to the commencement of the natural groundwater, or else the base flow. So this represents the withdrawal of water from storage build up in the watershed during the initial phase of hydrograph. And when the rainfall has stopped and the channel flow is due to the storage, then the point of inflection on the falling side of the hydrograph denotes this. Means that is the rainfall has stopped, right? And also the channel flow is also getting down. And the shape of the falling limb is purely dependent only on the physical features of the channel. So that's what we are saying about the basin characteristics, right?